Hello everyone. So in this question it is given that the reaction of zinc with dilute and concentrated nitric acid respectively will produce what are the products which we are going to get for this. So the first reaction, that is zinc when treated with dilute HNO3, and HNO3 is a strong oxidizing agent. So what will the products we are going to get is going to be, if I write the balanced reaction, I am writing here the balanced reaction. I am going to get 4 zinc nitrate, 4 moles of zinc nitrate plus N2O plus 5H2O. So this is the product which I am going to get for the zinc treatment with dilute nitric acid. And when I treat this zinc with conc HNO3, concentrated HNO3, so this what will happen is the concentration of HNO3 is increasing. So the product I am going to get zinc nitrate again, but here since the concentration has increased, so I am going to get NO2 plus H2O. So if I write the balanced equation would be 4HNO3, then 2NO2 and 2H2O. So this will be the balanced reaction. Now if I see for dilute HNO3, I have got N2O as the product, and for conc HNO3, I have got NO2 as the product. So N2O and NO2 will be the concentrate options. Let's see which option is there. If you see the option number second, so option number second has the option that N2O for dilute HNO3 and NO2 for concentrated nitric acid respectively. So this will be the correct answer. Thank you.
Hello everyone, let's start the question. The geometries of the ammonia complexes nickel 2 plus, platinum 2 plus and zinc 2 plus respectively are. So according to given ions, given species, we have to write first of all their complexes. So complexes of nickel, platinum and zinc according to with ammonia. So we write that with ammonia, nickel forms nickel NH3 all 6, 2 plus platinum NH3 all 4, 2 plus and for zinc it forms Zn NH3 all 4, 2 plus. Okay, so as we know that NH3 behave as a strong field ligand, so we can see here nickel with nickel and platinum, it forms inner orbital. It forms inner orbital. Inner orbital in the sense it behaves as a strong field ligand, but in case of zinc NH3 whole 4 2 plus, it forms as a outer outer orbitals. Outer orbitals in the sense it behaves as a weak field ligand. Okay, so hence the geometries for these options of it. Okay, so it forms tetrahedral uh, because of weak field ligand, and these are forming of strong field ligand, so they forms only octahedral as well square planar. Octahedral as well square planar means option first will be correct here. Octahedral, square planar, tetrahedral. That is your required answer of this question, and thank you very much for that.
Hello students, let's start the question. Which of the following compounds is not yellow colored? So we have 4 compounds over here. Yes. And how do we talk about their colors now? Now basically the colors from what the compounds are trying to show us is due to the approaching ligands. Okay. Now barium chromate is definitely going to show us a wonderful color, and that would be due to the charge transfer phenomena. Yes. So barium chromate is definitely yellow in color, and that is due to the charge transfer that it is able to show us this particular color. Yes. Whereas K3CONO26 or ammonium tetraarsenic molybdate, these two in fact, are colored because of DD transition. What is it? DD transition which takes place. Yes. Now, according to our spectrochemical series, yes, whenever we have a strong ligand approaching the central metal atom, okay, or the metallic species, usually what happens is that the strong ligand, they have a higher energy, okay. In fact, the strong ligand complex, what I'm speaking about is the strong ligand complex possess higher energy, yes, which means lower wavelength, yes. And due to this, what we have is the complex being colored of a lower wavelength. So that is for your ammonium as well as for NO2. Okay. So may it be for the ammonium ligands or for the NO2 ligands, or you could also talk about for instance, oxide, O2 minus. All of them are going to show us colors. They show yellow color basically. Yes. But what happens about CN? CN minus ligand is generally going to show us a white color. Okay. So basically Zn2FeCN6 shows us a bluish white color. Yes. And that is of course due to the ligand presence. It shows a bluish white color. Yes. So in that case, Cn minus being a very strong ligand, it would be showing me this color. Whereas NH4 plus, NO2, O2 minus, they are a little farther away from the Cn minus 1 and hence they would be showing yellow. In short, we are having only one compound over here, that's option number 4, that's Zn2FeCN6, which will be showing us a bluish white color. Rest of them are yellow. I hope you understood the explanation. Thank you.
Hello everyone, this is our question. Let me explain it to you. Which series of reactions correctly represents chemical reactions related to iron and its compounds? So the first is saying iron on treatment with chlorine and heat is giving FeCl3. That is absolutely correct. Then we are doing heating in the presence of air and we are getting FeCl2. Reduction is shown here, but this is wrong. When FeCl3 is treated in the presence of air and heated, then there should be oxidation and not reduction that should take place. Oxide formation should be there. Okay, so this cannot be the answer. The second is saying iron on treatment with oxygen and heat is giving us iron oxide Fe3O4. That is right. And on treating with CO, then we are getting FeCl2. That is again correct. And then further on treating with CO and heat, we are getting iron metal. This is absolutely correct sequence. The next one is saying iron on treating with dilute sulfuric acid is forming FeSO4, and then on treating with acid in the presence of oxygen, we are getting FeSO4 whole thrice. Okay, Fe2SO4 whole thrice it should be. And then we heat it, then we will get iron. This is wrong because sulfur components should also be obtained here in the form of sulfur dioxide, trioxide generally, and there should be the iron oxide that we should be getting Fe2O3. So this is a wrong reaction sequence. The last one is Fe on treating with oxygen heat is giving FeO. That is correct. And on treatment with dilute sulfuric acid, we are getting ferrous sulfate. Now on heating, we should not be getting iron, but rather the oxide of iron. And apart from that, sulfur compounds, sulfur dioxide, trioxide generally are evolved out here. So this is also wrong. So only one sequence is correct, and that is the second one. This is true. B. Okay. Thank you.
Question is, 4 successive members of the first row transition elements are listed below with atomic numbers. Which one of them is expected to have the highest E0 M+3 or M+2 value? ठीक है, तो हमें यहाँ पर बताना है कि ई नॉट की हाईएस्ट वैल्यू किसकी होगी। ठीक है, तो देखो क्या होता है, जब लेफ्ट टू राइट जाते हैं ना, जब लेफ्ट टू राइट जाते हैं, ठीक है, डी ब्लॉक पीरियड्स में, कहाँ पर जाते हैं, डी ब्लॉक पीरियड्स में, ठीक है, तो जो वैल्यू होती है वो क्या होती है, इंक्रीज होती है। ठीक है, वैल्यू क्या होती है, इंक्रीजेस, वैल्यू इंक्रीज होती है। तो जो एसआरपी वैल्यू होती है, ठीक है, तो जो एसआरपी वैल्यू होती है वो भी क्या होती है, हाइयर होती है। ठीक है, एसआरपी वैल्यू एक्सपोनेंशियली हायर, exponentially higher due to the stability of production, stability of production। ठीक है, अब देखो, अब इनके अगर अपन ई नॉट वैल्यूज की बात करें तो यहाँ पर क्या होता है, जो ई नॉट CR3+ और CR2+ की जो वैल्यू है वो होती है -0.41 वोल्ट। ठीक है, इसी तरह से Mn की जो होती है वो क्या होती है, वो होती है +1.57 वोल्ट। ठीक है, Fe यानी कि आयरन की जो होती है वो क्या होती है, वो होती है हमारी +0.77 वोल्ट। ठीक है, और जो कोबाल्ट की यानी कि CO की जो होती है वो होती है +1.97 वोल्ट। ठीक है, ये होती है। अब यहाँ पर जो, जैसे कि मैंने आपको बताया, जो स्टेबिलिटी प्रोडक्शन के कारण एसआरपी की वैल्यू जो होती है एक्सपोनेंशियली हाई होती है, तो सबसे ज्यादा किस किस की होती है, तो देखो सबसे ज्यादा तो होती है कोबाल्ट की, और उसके बाद जो होगी वो होगी हमारी Mn की यानी कि मैग्नीज की। ठीक है, तो यहाँ पर हमारा कौन सा ऑप्शन सही है, हमें बोला गया था हैव द हाईएस्ट ई नॉट वैल्यू। ठीक है, तो किसकी होगी, वो होगी हमारी CO की यानी कि कोबाल्ट की, तो यानी कि क्या होगी +1.97 वोल्ट।